In this video, we'll be looking into the given problems, that is elimination of left recursion from the grammar given. So firstly, they have asked to consider the following grammar and eliminate left recursion. Before moving on to the question, we need to write what left recursion is. So A derives A alpha 1, A alpha 2, beta 1, beta 2 till beta n. So if the grammar is of this form, then it is said to be left recursive. So from this, we need to eliminate the left recursion. So for that, we'll write A derives beta 1 A dash, beta 2 A dash, and so on till beta n A dash. So this is our second equation, and our third equation is A derives alpha 1 A dash, alpha 2 A dash, so on till alpha n A dash. Along with that, we write epsilon here. So this is our third equation. So our main aim is to consider all these productions and convert it into this form. Okay, if there is left recursion in any of the production. So let's consider the first production now. Let's take this as grammar G. So let's write the first production, that is S derives S minus B, S star A, E and ID. So here if I write the first equation, if I compare the first equation, so it would be A derives A alpha 1, A alpha 2. As there is no, we can make out that S refers to A. So is there any S here? No. So it starts from beta productions. So let's write beta 1 here and then beta 2 here. So here we'll write A is equal to S. So A dash would be equal to S dash. Then we have alpha 1. So alpha 1 would be minus B. Alpha 1 is minus B. And then alpha 2 would be star A. And then we have beta 1 equals to E and beta 2 equals to ID. So converting this was our first equation, right? So now let's convert first equation to second and third equations. So A derives beta 1 A alpha, A1. So A here is S derives beta 1. What is beta 1? E. A bar is S dash, A dash, S dash. Yes, E dash, S dash, and then we have beta 2, that is ID, and again A dash, that is S dash. So here we have written in the second equation form. Now looking into the third equation form, it would be A dash derives alpha 1 A dash. A dash is S dash derives alpha 1 is minus B, A dash. A dash is again S dash, then alpha 2 A dash, alpha 2 is star A, S dash. Is there alpha 3? No, there's no alpha 3. Finally, conclude it with epsilon. Yes. Now let's look into the second production, that is B derives B, D and E. So this is pretty simple. A derives A, this entire thing is alpha 1. So here A is equal to B. So A bar would be equal to B bar, and here alpha 1 is equal to D and E. And there's no beta here, right? So let's write epsilon here. So the production would be B derives, as there's no beta, we'll take it as epsilon. Here we'll write beta 1 A dash, that is epsilon A dash or B dash here. So we have written second equation. Now let's write the third equation, that is A dash derives alpha 1 A dash. Alpha 1 is DE A dash. Here it is B dash. Is there any alpha 2? No, there's no alpha 2. So we'll write epsilon here. Next, moving on to the last production. Moving on to the last production, here we have A dash, A and B here. So we can make out that A and B are the non-terminals here, right? A and B are the terminals, sorry. So when terminals are there, no left recursion exists. So we can write this as it is. We can write the production as it is. So E derives A and parenthesize B. So this is the final output. That is a grammar which is free of left recursion. So this was our first step to eliminate the left recursion, and our second step is to write this again. So write this again write this again down. So that's the answer. Now let's consider the second question here. So here there are two productions. Let's take this as G. So if you look at the first production, there is no left recursion in production of S. But if you look at the second production, there lies indirect left recursion. So in this case, first production, don't check, write it as it is. Let's from the second production we need to start. So A derives A. So what we'll do is we'll replace the value of S with AA. Okay, so we'll write AA S and then 0 S and 1. So in this step we took the next production, replaced first production with all possible meanings. So whenever we obtain a direct left recursion, solve it accordingly using equation 1, 2 and 3. So let's start with this. Let's compare this with the first equation, A alpha 1 and here beta 1 and here beta 2. So the answer would be, here A is equal to A itself, A bar is also equal to A bar itself. Then we have alpha 1 which is equal to AS and beta 1 which is equal to OS or 0S and beta 2 is equal to 1. So we can write A derives, this is the second equation I'm writing, A derives beta 1 A dash, beta 1 is OS A dash and beta 2 A dash, beta 2 is 1 A dash and beta 3 is not there, so this is our second equation. Then we have, we'll write the third equation, A derives alpha 1, alpha 1 here is AS alpha 1 A dash. And then is there alpha 2? No, there's no alpha 2 here, so let's write epsilon at the end. So from the second equation we have obtained two productions. So if we have taken this as grammar G, right? So let's write GLR, grammar which is free of left recursion or after left recursion. So it would be S derives A0, the first production as it is. Then we have A derives 0S A dash, 1 A dash, and A dash derives AS A dash and epsilon. So this is our actual the set of productions after elimination of left recursion. So I hope you have understood how to solve given any grammar, how to eliminate the left recursion. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.